Hi, good evening. My name is Francois Tang, and I'll be presenting the work on the pallet scale factories. So I'll be speaking on behalf of Irriba Laser, Avio Aero, and the NTC, and we had the audacity to call ourselves factories, albeit pilot scale. But we aim to have four main objectives within the AMAZE. One was to, establish them and to the level that we were industrial and became a tier one supplier of material. The other one was to come up with a modular, streamlined workflow to offer maximum processing flexibility. The third clear mandate we had was to demonstrate an ability to build 10 components within a working day, all the while promoting waste elimination and streamlining. So AMAZE is a European project, so the factories are spread across Europe. We're now here at the MTC, but Avio has facilities in Cameri, Italy. Irriba is located in the beautiful city of Strasbourg, and we are down in the woods of Norway, north of Oslo, in a little town called Hønefoss. So I'll take each of these factories and try to explain how we call ourselves factories. So we use a process trademarked as the rapid plasma deposition, or RPD for short. It's basically a wire arc process. This is a picture of our factory layout. So material comes in. Since it's a wire arc process, the type of material we receive are typically wire and substrate plate. This is brought into our quality control area, where we make sure that the wire is up to our spec, and so are the plates. We have to undergo a cleanliness process because our substrate plate come in quite greasy, greasier than my morning bacon. Then the substrate plate go towards our clamping area, which then are fed into 3 different machines. So right now we have 3 what we call RPD machines running. These, after the RPD process, these our preforms are controlled against their dimensions. So we do a 3D scan and compare with a CAD model. All our post-processing operations are performed outside. That includes the machining, NDT, and heat treatment. But eventually, the parts find their way back home, where we perform our internal quality control before being sent out for any customers. So Norsk was, until very recently, a technology development company. We made mini machines. Eventually, we came out with our 4th generation machine, which is intended to be our industrial machine. It's intended for large-scale production. It's no longer intended for research and development. One of the aspects of it is the in and out hatch that allows us to keep a closed environment, prevents us from opening the cell because it's an argon environment. We can do an in and out within 5 minutes. We're now running 24 hours continuously, and each machine has the specification to produce approximately 15 tons of Ti-64 wire arc additive material. Now going into the process, what you see here is the welding tool on the top. It actually contains 2 torches. One torch is used to prep the surface, heat up the surface, and the other one actually melts the wire and maintains the melt pool underneath it. The torch stays stationary mostly. It moves up and down. The movement is provided by the table underneath it, which has a 3-axis motion. X, Y, and what we call the Z-axis. We have a part envelope of about 900 times 600 times 300 mil. That was our sweet spot that we found where we could produce the kind of parts we aim to make. The dimension of our layers are about 3 to 4 millimeters, and the beads are about 8 to 12 millimeter. Well, that's depending on the traverse speed and the wire feeding speed. Deposition rate, typically we operate around 5, but we've pushed the machine and go somewhere to 10. And we keep a closed argon environment because titanium is like a sponge to oxygen when it's hot. So one of the achievement that we've been recently very proud of is that we've achieved the production status. This means that over the course of 46 hours and 12 minutes, we produced the same component 20 times. That component has particular value because it is an actual OEM aircraft manufacturing part. These will be flying parts. But this, I think, is a clear achievement of the fact that we've been able to make 10 components within a day. Having said that, all the post-processing operation are still performed outside. We tend to focus on the RPD process, and we rely on outside partners for the rest. So I've been speaking for Norsk, but I'm sure my colleagues Pedro sitting over up there, and for the true Norwegian experience, Hilde will be quite happy to answer your questions. I'll be now speaking on behalf of Irriba. Irriba is using a blown powder laser process. So their factories is described in this schematic diagram that shows a quite similar process to ours. So the material comes in, it's controlled for quality. They have a storage area for their powder and their substrate. Irriba being a laser guru, they have their own in-house substrate cutting facilities, quite envious to that. Still goes then to substrate clamping, and then they perform their clad process. That's the trademark name for blown powder laser process. Following the deposition, the part undergoes a visual control. And all the post-processing operation are also performed outside of their facilities. But then the part are returned for inspection and then customer delivery. Their working machine is the Magic machine. It is a 5-axis machine, so the left-hand side of the picture shows the Y, X, Y, Z movement, and also the B and C rotation movement. It has quite large building envelope going from 1,500 to 840 to 700 mil. And they have a continuous motion on their C-axis, which is also something we're quite envious about. It has 2 nozzles, so that allows them to, for continuous operation, when one nozzle is empty, they can move on to the next one, fill the empty nozzle with fresh powder. The glass enclosure is 12 meter cube, which is kept at an oxygen environment of 40 ppm and an O2 and H2 environment of 50 ppm. So they have one machine that is operating, that can be operated over a continuous 24-hour period over 3 shifts. This is a picture of the build chamber with the AMAZE demonstrator still clamped inside. So that demonstrator is now sitting in our demo area behind. The intention of this build was to demonstrate long duty cycles. I believe that there was that took over 100 hours to build. at a deposition rate of about 70 centimeter cube per hour. These are other kinds of large-scale structures that Irriba has been doing during the project. So on the left-hand side, this is another AMAZE demonstrator called the made for BAE systems. It's over 1,000 millimeters in length. And on the right-hand side, you've got the two-size cylinder. One was a half-scale built, and the other one was a full-scale built. Having said that, Irriba the process by Irriba laser is particularly suited for small-scale structures with thin-walled. So keep in mind. Now moving on to the third of our factories within AMAZE, we're going to in Italy. The factory is located in Cameri. It was built in 2013, so it's quite recent and has quite a large square footage. It's home to 3 DMLL, so I think they have, those are EOS machine and over 20, just 20 EBM, electron beam machine. So it contains a training center and a lab. But one particularity to it is that they have their own gas atomization facility system. So I think one of their main business is this electron beam melting process, which they use for Ti-64 and gamma titanium aluminides. So that's over 20 machines. The machines are the RCAM2XX that deposit as a rate of 50 centimeter cube per hour for application of low pressure turbines and aero engines. Their direct direct metal laser melting process can use various metals, going for titanium 64 to steels to cobalt chromium to cast alloy to aluminum to Inconel, really the whole catalog of material. They're using various EOS machine going from the M270 to the M280 and the M400. The deposit for these machines at a rate of about 10 centimeter cube per hour, but these are for prototypes and development purposes only. So the particularity of Avio Aero is their ability to atomize their own powder. So they have the ability to atomize Ti-64, titanium aluminide, and pure titanium. Has a capacity of about 50 tons per year, and using precise ingot alloys as a feedstock material. So that allows them to control their own quality, in-house for their powders. And finally, the last factory we have on our list is the MTC. So I won't pretend to give a better tour than David will this afternoon, but the MTC EBM lab, electron beam lab, is located, I think, in, well, I need to move my camera, okay. I think it's located to the bottom of the picture. There's a powder processing facility on the top right. And the metrology that is performed with a GOM system, so that's a 3D scanner system, an XCT, and CMM machine are all performed outside in a separate metrology lab, as are machining facilities. The MTC has a cluster of four RCAM machine that have been used to manufacture the demonstrator within AMAZE. They have a built envelope of a cylinder of diameter of 380 mil and 380 mil in height, which is mostly used for Ti-64. One thing that David will not be able to show you is the factory within a software. So the MTC developed a simulation system called the Discrete Event Simulation that shows how the material flows through a series of processes that here are described by the light on, light off icons. So it takes a set of complex operation and splits them to the slowest level. And it also describes the interaction between each of the processes. There's a dynamic and stochastic relationship that is established, and then that allows you to visualize the full process from material in to components out. The data is generated using individual, the data input also contains the timing for each of the processes. That includes the setup, the manufacturing, the powder removal, the dimensional inspection using the GOM system, machining and hipping. So why would the MTC go through the process of creating a virtual factory? Well, there are several benefits to that. One is to provide this bird's eye view of the system. It gives an idea of the optimal design of a factory without ever purchasing one single machine. It finds the capacity and the opportunity where to increase asset utilization. It also identifies potential multi-skilling operation where one operator might be able to split his time between two tasks. It reduces capex for the by identifying operations that are really worth the investment and then at the expense of others. And these results are then can be visualized, and in the case of AMAZE, we looked at the APOD 2, so that would be the Bombardier hinge, to say that in order to achieve 10 parts per day, the ideal setup would consist of 9 E-beam machines and 3 CNC centers. That was, there was a fairly conservative assumption of about 30% failure rate in those numbers, but that is to say that a much higher production rate could also be achieved should that failure rate be slightly lower. That also involved 11 staff to run the factory, but this simulation highlighted the fact that multi-skilling is advantageous and could reduce that number to something lower. The factory layout was created to demonstrate production route through this visualization. So we've been describing the factories without really focusing on waste, but within AMAZE, I think there's four of the factories looked into waste, and waste in terms of time for the case of Norsk. So we were very clear when we developed the 4th generation machine that we needed this closed deposition cells, and we wanted no opening of the cell to remove or insert a new component. So, and that is now the case for the 4th generation machine. Irriba uses a dual powder powder feeder in their system that prevents them from having to wait while the powder feeder is being refilled. They also use their in-house, their own in-house substrate cutting to avoid the shipment and the receiving of cutting substrate. The same kind of vertical integration is being used at Avio Aero, where they produce their own powder atomization as a means to avoid having to deal through the complicated loops of supplying their powder. And lastly, the MTCs developed this really nifty tool to simulate the events happening in the factory to quickly identify where gains are possible. So as a summary slide, I'm finishing just in time for lunch. So I think we can fairly claim that 4 factories have been established within AMAZE at various levels of maturity. But the AMAZE project has definitely accelerated that achievement. Seeing where we were 4.5 years ago and where we are now, there's a clear advance towards production and being able to satisfy the demand for additively manufactured parts. But we all understand that this progress doesn't stop now and will continue to grow for the future, whether it's by making new machines or by increasing our part production capacity. And at this point, I'll be happy to take her questions. I'll also highlight that Jérôme from Irriba Laser is sitting on the 7th row. And I can see Danielle, sitting also in the room on the same row as Jérôme, so they're probably your best chance to get a clear answer on their factories. And David's just here.
I want to point out that with those that are doing the tour, the NTC factories isn't as described there. There's been some changes, and actually what we have, when we first started, we had 2 laser melting machines and 2 archive machines. You'll see that things have changed since then. So I think it's been sort of a head count. The head count isn't quite as it was on the slide. I think what's interesting about the discrete event simulation is often we focus on the very expensive bits of equipment and find the bottlenecks are in very basic stuff that can completely slow down the whole production. So you can get too besotted with the expensive, flashy equipment, and it actually ends up coming the number of buckets or the number of rooms to clean up parts, which don't cost very much, but can completely muck up the production rate. Any questions for Francois or the other team members involved in the factory?
I'm sort of curious about the Avio incorporation of the atomizer with the plant as well. Is there an indication of how much of a cost benefit there is to having to operate your own atomizer system over just bringing up a powder supply and demanding certified powder?
Unfortunately, I'm not involved in the issue about the atomizer because they are in a separate plant and I don't follow that operation.
I think it's a good question, I think having an atomizer is both a boon and potentially an awful white elephant if you're not careful. You have to keep it busy. And so I suspect that Avio, to keep it busy, will end up also having to sell powder externally. Otherwise, you're not using the atomizer to its full capacity.
Yeah, of course, that's the aim, to use the powder for ourselves and to sell also for third parties.
Don't all rush out on that atomizer yet. I think there's a question about, this isn't straightforward. In my presentation this morning, I mentioned about the issues of powder quality. It's always easier to phone a supplier up and give them a piece of your mind. When you're making your own powder, you've got no one else to blame but yourself, basically.
It was just an additional comment there. I think Avio is a particularly unique situation in the alloys that they're interested in, and the scarcity of them or the stability of the existing supply chain was probably more of
1:15 in the foyer. We're going to sort of across in a couple of groups because otherwise we'll overload the reception over in the MTC. You must remember to bring your identification document so that we can cross-ref, and also your name badges, so that you can actually cross-reference the two things together. Okay. So enjoy your lunch and make sure you network.